All right, ready? Let's do it. Where y'all want to start? Anybody look at the notes before? Or like the announcements thing? Or the notes recently?
The announcements where you tell us like what is it?
Yeah.
Yeah.
Okay, that's a good place to look. If you haven't looked, this is a great place to look right here. College algebra, lecture notes. You got test 2 review, and you got this click here button. It's probably a good idea to click there before whenever the test is. Tuesday. So maybe click there before Tuesday, and it'll help you know what to study. Maybe it'll disappear too. So who knows? Take a picture or something. Did you get a haircut?
Yes.
Looks good. Good job. Sorry if anybody else got a haircut. All right, here we go. Oh, you thought we were going to skip it. We're not skipping it. 3, 2, 1. Fix it. But it's worth. Put it on a desk. Somebody asked me to record. Said they wanted me to, and I said I would. Take way more work than I thought it would. No, I think this is fine. That's it. All right, you ready? Here we go. Anybody have anything to start before I just start, I guess? Because we won't have time to do every single question, so it's worth doing the ones that are harder that you couldn't do on your own.
2B.
There we go. That's what I'm talking about. 2B.
Actually, no, 2A.
Okay. 2A?
Yes.
Sure. Yeah, 2A is a little harder. And 2A looks a little more like the test. So, you're welcome. Let's put it over here and get started. All right, 2A. Name? What's that thing called?
Piecewise function.
Indeed. And a piecewise function just tells you to do literally one thing.
Okay.
Yeah, just plug it in, right? But you have to plug it into both. Yeah, you need to plug it into both and see which one makes more sense, right? So, first things first, what are we plugging? Oh, yeah, actually, the better question is, what are we plugging in? The thing, right? That doesn't change whether it's piecewise or nothing. You see the F little parentheses? Your brain should think plug in. Okay? So then where are we plugging that -2 into? Anywhere we see an X. Not just the top, not just the bottom, not just the left, not just the right of the little semicolon or colon, but anywhere you see a X. So I'm going to plug it in right here. If 2 does not equal, oh wait, that's a -2. If -2 does not equal -2, that's kind of worded weird. Does -2 not equal -2? It's kind of worded confusingly, but it doesn't, right? Because if we plug it in down here, this says if -2 equals -2. Which one of those makes way more sense? The bottom makes way more sense, right? So we can literally just go cross out the top. Look at that. And if we cross out the top, then you know what we keep doing? We already wrote it in blue once. Absolutely, you just keep plugging it in everywhere you see an X. So now we've got 3 times -2 plus 1 equals -5. And we write it like this. The set of the answer, which is -5. Also known as f of -2 equals, ooh, and here's the real thinking question. What is that? We talked about this last. What is this? This right here is something. What is that?
Why?
No, it's not y. This whole thing. What is this whole thing? No, it's not a function. It's a point, right? It is a function, and it is y, and it is x. But if you put all those things together, it's a point, right? What's that point? Okay, our brains really do want to see that that's a point. Our brains really want to see that every time you see that little F parentheses something something, it's a point. Yeah.
On the test, we need to do like all that.
No. We're just exploring. This is it. That's it right there. Sorry. I should have done that. This is just us exploring. And actually, here's another exploration. is while we're here, just in case, they give you the harder one instead, because the top looks harder, right? So let's make up a question that would have gone with the harder one. F of what? Literally anything else, right? Literally anything that's not -2 would go with the top one. The only case that goes in the bottom one is -2. So let's call it 4. So what is f of 4? Well, let's check it in here. Is 4 not equal to -2? Yeah, that satisfies that condition. Is 4 equal to -2? No. So we don't want the whole thing. We don't want to mess up later. We cross out the whole dang thing and say we don't want it now. So f of 4 equals 4 squared minus 3 over, which probably is just like 13 over 18. Something like that. Again, that's just us checking to see can we do multiple types of the same problem. So I might say if you were looking at that and you wanted it more neatly organized, you'd probably say f of -2 equals -5, and f of 4 equals 13 over 18, ugly as it may be. Those are just the 2 types of problems you could be asked on that. There's really no other ones. Okay? Not too crazy. Piecewise function. It will look just like that. It'll look just like that. Sometimes they have the greater than or less than sign. But then you just check that condition and say, is this number greater than or less than the other number? Good to go. All right? Piecewise function. Hopefully that's not too bad. What else we got from the review?
Repeat question like 2C on the test.
Possible. I don't know. I don't have them memorized. What is different about 2C?
It has the...
Ooh, the whole number is weird. Actually, I do maybe remember a whole number, but I can't remember for sure. I do maybe remember one of those whole number answers. I can't remember 100%, but it seems familiar to me. That top answer, which is kind of wonky. All right, so let's just look at the one. Let's not like go in a whole bunch of tangents. But if we're just looking at that one, where do we plug the 4 into? Everywhere. Is 4 less than or equal to 2? So, we don't want it, right? Is 4 greater than 2?
Yes.
Check. So we plug it in. So f of 4 equals 4 plus 1 squared, which is probably like 25. Okay, I lied. We are going to go on a tangent. Because I want to check the top one too, right? So someone other than Nelson, give me a number that would plug into the top and not the bottom. 1? Let's check and see. Do we agree that 1 would go in the top? Is 1 less than or equal to 2? Is 1 greater than or equal to 2? Nope. So we do use the top. All right. So that would mean that f of 1, we plug it in everywhere we see an x. Where do you see an x? So yes, that's the hard part to recognize. You plug it in everywhere. Like, so right here, we plugged it in everywhere we saw an x, and we wrote the thing out, right? Same thing. Plug it in everywhere you see an x, and then write the thing out. There's just nowhere to plug it in. That's a good question. That one is kind of weird. Because you're like, well, there isn't one. Is it 0? Some people might jump to. But no, you write what you see and plug in the x's. Because if you're going to read this from left to right, this would say this function takes some number x. And if that number is less than 2 or equal to 2, the function spits you out with the number -6. And that function, if it's greater than 2, spits you out with this parabola-looking thing that looks like the normal parabola shifted to the left one. If we're really remembering everything from class. And if we were to graph that, and I said no tangents, here we are. If we were to graph that, then it probably looks like there's a red line happening at 2. Pretend like that's 2, right? And to the left of 2, what is the y value?
4.
Oh, careful. Where'd you get a 4?
No.
I'm saying there's something happening at 2 wonky, right? If it's to the left of 2, you're left. If it's to the left of 2, what's happening to that y value? don't know. Ooh, this is a good question. If x is over here, what do we know about y? It's a negative, and more specifically, it's always a -6, right? 1, 2, 3, 4, 5, 6. Watch this. It is always a -6, right? But if it's bigger than 2, what is it? It's that parabola shifted to the right, right? Yeah, it does start at 9. It starts at 9, and it's just a normal parabola. It's kind of weird, right? But I mean, it's a good thought to say, can I graph these too? I can't remember if we have a graphing thing, but I do know it's a good thing to know. And yeah, I think you're right. The 2 would start it at 9, right? Because 2 plus 1 squared is 9. Now, does it include that point? The reason I put an open circle at the top and a closed circle at the bottom is because we're including the 6, but not the 9. Still gets super duper close to 9, right? At 2.11111 or 2.00001, super duper close to 9. But it's not 9. Okay. That's good for piecewise. If you can do the first one, you'll be golden. If you can do the second one, you're more than golden on piecewise. So maybe go practice B on your own and see. All right, what else? 3B. Yes. 3B. This will be the hardest type on the test. I will tell you now. This will be on the test and it will be on the final. Pretty much, I see this so often. This difference quotient thing. It's pretty common. So here we go. And it is not difficult. It is just annoyingly long. You'll see that as we go, and we'll be super duper careful with our numbers. This difference quotient thing is not super difficult. It is just annoyingly long. So 3B. Okay, so if you're going to start one and you see that ugly formula, I guess the best way to do it would be to break it into 3 distinct chunks. Do this green chunk. Do this blue chunk. Leave the minus sign alone. And then I guess the red circle is fine. It's already done, right? All right, so let's look at doing that green section. And say F. Oh, that was no time at all. Oh, well. They're still recording here. F of x plus h equals. Okay. What are we plugging in for x? What are we plugging in for x then?
We put 0. We use 0.
Why would you use 0? What are we plugging for x for that piecewise a second ago? Like a 2 or a 4? How did we know what to plug in?
Anything that doesn't equal.
No, how did you know what to plug in? You looked somewhere. How did you know what to plug in right here? How did you know what to plug in? It gave you something inside of those parentheses, right? And how did you know what to plug in here? Because everybody yelled it right away. It gave you something inside the parentheses. So how should you know what to plug in here? It gives you, yes, man, exactly. X plus H is your thing. Is it ugly? Yes. But you still can do it. It's just a thing. So instead of X, what are we going to have every time? This X plus H, right? So watch this. We're doing B, right? Okay. So 3. Oh, I see an X. What should I put in instead of the X? And what did you put in before? A 4. And what did you put in before? A 2. This is just a weird thing in the middle, but it's okay. X plus H squared. Plus 2 times X plus H plus 1. Is that allowed? Yes. Is it ugly? Sure. So now we got to do a little foiling probably. Well, we're done. We're done. Yeah. What's up?
We're like doing that top equation. You don't like subtract the f and the x like
No, we're going to. We'll do the blue thing next. Yes. See how that's a green? Then we will subtract whatever is blue, f of x, and then we'll divide it by h. I'm just doing it in 3 small chunks so we don't get all convoluted and start getting ahead of ourselves. Because first we need to do what PIMDAS says to do first, which is parentheses, exponents, multiplication, division. So I think the first thing we can do is that exponent, right? Because you can do a parenthesis thing, but can you combine x and h if you don't know what either of them are? No. Yeah. So we tried to do the thing that's inside the parentheses. We couldn't. So we move on to exponents. So let's see what we have. We have 3 x squared 2xh plus h squared. And I'm going to just not do the distribution yet. We can do all the distributing together in one step. That step was just us doing FOIL. And the next step is us doing distribution, which is like that little rainbow arcy thing, right? So now we should have 3x squared plus 6xh plus 3h squared plus 2x plus 2h plus 1. Are there any of them that have the same variable and the same exponent? I don't believe so. So, whoa, that's the green answer. That's the green answer. Now we must do the blue answer, which is actually done for us, so that's super nice. The blue answer has been taken care of for us. So what is our blue answer, this f of x? It's just the normal thing, right? It's taking an x and plugging it in for x, which would spit you out the normal function. So the blue function is 3x squared plus 2x plus 1. So what must we do with those two functions? Subtract them. And if what's about to happen will always happen. And if it doesn't happen, take a breather, try a different problem, come back to this one later and try again, starting from scratch. Because what's about to happen with these two functions is always going to happen every time. So let's see what happens. I'm going to write it back in green just so we can kind of see. 3x squared plus 6xh plus 3. I'm sorry that it's so ugly, but you write it carefully. And then what are we doing in the middle? And then there's such a common mistake that's super easy to make. You're not subtracting the first term. You're subtracting every term, right? So I'm putting parentheses around it so I don't mess that up. We're not just subtracting 3x squared. We're subtracting that whole dang blue thing, right? Which means I got to distribute that negative sign, right? So it turns into a negative, negative, negative. And then what really cool thing just happened? I'll do it in pink so it can be a different color. Just pick one random thing to see if it happens or not.
Why did you turn negative? I'm sorry.
From the negative sign up in the top of the problem. See this minus sign in between this pink thing right up here?
Mm-hmm.
There's a negative sign right there. So I subtracted the green thing. See, green thing is green thing. Black minus sign is the same black minus sign.
Mm-hmm.
Blue thing is blue thing.
Okay.
And
But why did the blue thing
turn negative?
turn negatives now?
Because we've got this minus sign here,
But that carries it.
which I turned it into a plus sign and I distributed it
Okay.
across, which you're allowed to do. And if you don't like that, you can think of it as multiplying by -1. And I distributed a -1 across the board.
Okay.
And if you don't like that, well, there's only two ways. I don't know another way to picture it. You just have to know in your heart, you're not subtracting 3x squared. You're subtracting the whole thing, right? Like, look, we subtracted that whole blue thing. Not just the first term of the blue thing, which the first term of the blue thing would be this. And if I didn't have those parentheses there, it would just be saying subtract the first one and leave the other two positive, and that's not how the subtraction happens. Yeah.
So when we do that with every single
Yes. Yes. Anytime you have any subtraction of a function, it's subtracting the whole function, not just the first term of the function. But it's so common. It happens all the time. It's a super common mistake. Okay, so what do you see that happens really cool?
the 3x squared.
Okay, but I posit there's more. Do you see anything else cool that happens? 2x and 2x. And I posit there's one more cool one.
And 1.
The 1 and the negative 1. That's why we needed to distribute that negative, because it's going to do that every time. It's going to do that every time. And if you don't get those triple cancellations or double cancellations, depending on how many terms there are in your thing, then take a breather, try again, because it's going to happen. You can count on it. So now we've got 6xh plus 3h squared. But we're not done because we have the red section. Divide it by h. See that red h up there? We can't forget about that red section. And now something cool happens with that h. Take out the bottom one. Take out the top one. Take out the top one. Take out one of those squares. And we are left with indeed. Most of them. We left with one. But most of them. One. Just one. But it will be there. Yes.
I always had this impression that when you have like everything over one denominator is like one denominator canceling to one thing. Like I thought it was only one into one, like h into h, and then everything is the same.
No, it has to be every single term.
Everything because
Or you can't cancel it. If there's not an h in every term, you can't cancel it. All right. That is a good one to practice. That's a good one to look smart if you're going to the library and you're practicing on the whiteboard. That's a good one to do on the whiteboard and look smart in front of your friends. But really, it would be a good one to practice the other two on your own without me doing it for you. And when you struggle, send me an email and say, I can't get this one. I'll respond pretty quickly, especially over this weekend. If it's on Friday or Saturday, I'm just going to be watching football. So send me, if you're working on A or C. With these types of problems, you can make up anything in the world. You can make up any little function in the world and do it quickly. There's no like, oh, this was a bad makeup problem. They all have a really solvable difference quotient or derivative. It's that same process. It always happens. You can make up any numbers in the world. 300 plus 22 plus 1. It's going to work out nice and neat. That doesn't make it more complex. You just practice with any three numbers in the world. Yeah.
so you see how that little what you call it? It just had a green, blue, red, so divided by h.
Uh-huh.
That always be in every problem. Is that gonna also?
Yes. No, that is the difference quotient.
Okay.
And when you get moving on in your math careers, you'll be able to look at this, and I can tell you right now, this difference quotient is 2x minus 4. And I can tell you this difference quotient is 4x minus 4. So those are your other two answers. You'll get good at that. But like, because we do this difference quotient so many times, I can look at those two difference quotients and tell you that is that. Maybe plus 2h, honestly. Probably plus 2h. Maybe just 1h. I actually don't remember. But yeah. So if you're looking at it, those are your other two difference quotients, just so you know. But you'll get good at it someday. Practice, practice, practice. All right, let's hop over to this test review. What? No, we don't. That's halfway over. And we've only done 2 problems. There's like so many problems. No, we've done 2. No, we've definitely done exactly 2 problems. And that's half the time. What? 4. I got a 4? Oh, sorry, Amada. You got the next one. Hang on. We got a question on 4 real quick. Yeah, we can do it inverse since most people miss that day. And we really should do it then. Yeah, we should definitely do inverse. And then, all right, here we go. Copy, paste. All right, use the graph to determine domain and range. Domain and range should pop out in your brain that you think the letter right away. Which one's which?
Domain
X and Y. Okay. I'm only going to do one of these. Which one do you want to do? A, B, or C?
The third one.
The third one. Awesome. Good choice. Think about X. Think about X. And this is a great way to do it, honestly. Somebody was saying, hey, can we do that whole vertical line test, horizontal line test thing? I was like, yeah, let's do that. So if you think about X as this line, just work your way over and tell me when the function starts. Yeah, boom, right there at -4, right? So I'm writing that because the line hit it. Does it include or not include -4? Nope. Keep going. When does this function end?
Infinity doesn't.
It never ends, right? So how do I write never ends? Boom, just like that. And that's your domain. Done. Not too crazy? Same thing for range? And I think I think this whole line thing helps more with range than domain, because range is the one people mess up the most. So watch this. And we got to be so dang careful. This is kind of interesting. Tell me when this thing starts. I'm going to work my way up. Tell me when it starts. Oh, why there? Because we've technically got this line going forever, right? It had already started, and we didn't even see it.
So that's like positive.
No, careful.
Negative infinity.
So your range had already started, right?
Yeah.
But tell me when it ends. Right there, right?
Yeah.
At that one value. Not at... Some people are tempted to say like 2 because of the x number. No. We're looking at the y number, that horizontal line. Okay? Domain and range. The lines kind of help. You can do it with your pencil. Just going across and saying, where does it hit? Where does it hit? But the arrow, actually maybe if you see one like this on a test, it's probably a good idea to just take that arrow and go out till you hit the edge of your paper so you don't forget. Like literally. It won't be far away. Like if it's like this, it would be on the paper would be right there. Just do that, and then you won't forget that. Oh, that's going on forever when I check my range. That's a good one. All right, Amada, and then we'll do inverse.
It was one of the rapid fire ones. It's 2A.
Perfect. 2A is definitely going to be on the test. 1,000,000%. I know for a fact. Now I don't know that A is on there, but something that looks like 2 with a series of 6 questions will be on the test. So thank you for. That was actually the last thing I put on there because I was like, this is such a common thing to have happen where they give you a graph and they say, do a bunch of random stuff with that graph. So let's hop over and check this out. What the heck? Oh, there it is. All right. Zooming in. Use this graph to solve this exercise. I'll just do A for now, and then if we have time, we can go back and do B and C. But I like A because it's kind of tough. What is f of 4 minus f of -3? Well, I think I just like that last problem, I would see this as 2 distinct problems.
3 minus.
Well, hang on. No. 2 distinct problems. The blue problem. What is f of 4? How do I find f of 4? This is the 4 on the x-axis, right? And you go up till you hit it? Because the 4 is technically an x, right? The 4 is an x. And 3 is the y, right? That's a point. It's not a line. It's not an x-intercept. It is a point on a graph. All right, what about the red point?
-2.
Looks like -3 comma -2. Okay. So now I have to figure out what is f of +4 minus f of -3. Remember we said you can think of that little f as the y values? So the y values of each of those things is 3 minus, which is just a fiber.
Wait.
What's up? Wait.
Let's go to X up. I look for 4 and X axis, then go up and then go across to 3.
What's confusing? It's okay to be confused.
Okay, no, I got it.
No, don't lie.
No, yes, I got
Okay.
it.
Okay. Good thing to try is the domain and range. We already talked about it. Good thing to try on your own though is that B and C thing because heck, it's common. It happens. All right. I do think this inverse is a good idea though. It's really important actually. So it was just this last one? Chances are if it's last on here, it'll be last on the test. So find the inverse of a 1-to-1 function. Can we do C? Sure, we can actually do all of them.
Yeah.
Because we were all missed a lot. Whoa. How did that happen? You all saw me copy and paste it. It's right there. How did that even happen? Gee willikers. All right, here we go. Is that camera still on? No? Oh, why didn't you say anything? It's okay. Could you just text? Okay. All right. Does anybody remember from the one class when we were here? Does anybody remember like the steps? There's 2 or 3 steps really.
You want to put the function down, right? And then you equate it to f of x.
Okay, wait. You want to put the function down?
Yeah, just put x plus 4 bracket cube just equal f of x.
Oh, f of x equals all that crap? Okay.
Then you wanna, you know that f of x is y.
Okay, that was step 1. This is true. Just to write it as y. Okay.
Afterwards, you try you substitute. No. Hold up. You switch.
You switch. Everybody that was here and everybody that wasn't, inverse just means switch. Just switch them. X equals y. See what we did there?
Yes.
And now what?
You solve for y.
Now you get y by itself and you're done. That's it. It's just switching x and y, solving it out. That's all it is. So step by step, how do you get rid of a cube root? Or a cube? You cube root it. So we're left with the cube root of x equals y plus 4. How do you get rid of that 4? Subtract it from both sides, and you're left with y equals the cube root of x minus 4. Not a trick, not a joke. Another way to write it, if you're looking at that, would be acceptable, 100% acceptable. If you're working on a test though, and you're seeing multiple choice, they might write it with this little -1 symbol.
So if we graph that, it would be like.
We're not graphing it.
No, it'd be like trying to remember this.
If you graph it, so that's a cube root function. A cube root function, if I remember correctly, or a cubic function looks like that.
Yeah.
But this is a +4 cubic function. So what does that mean about it? This is a good review. What does that +4 mean about the regular cubic function?
Vertical.
Nope.
Go. Wait. What? Inside.
It's inside parentheses.
Oh, yeah, it's inside. Yeah. It's
So which way, left or right?
right. Left. Yeah. It's positive, so it goes to the
To the left.
left. Yeah.
To the left by
If it's negative, it goes to
4. See, that's not even part of this test, but that's good review to see, right? So that's that function right there. And then what Joseph said was the inverse is, you were saying the graph of the inverse is what? This is just thinking in.
It would be like x cubed.
You reflect it. You reflect it across a special line.
The y-axis.
No, that
X-axis.
you reflect it across that line.
Y equals 9.
This is just extra. You take every point, and you reflect. Oh, that's probably gonna be on the line. And you reflect it across that line every single time.
It's fascinating.
So it looked like the same thing, but flippy floppy. That's just how you can recognize the graph. I don't know if there's one on this, but it's good to, because you missed the day, go watch the video, go practice the notes. It's on there. That's a good review. Actually, I'm just going to leave you to do the rest. That's good. I'll leave you to do the other 2 to practice and watch the video because they're all in the videos. That way we can cover more info. Because now we're at 45 and we only have 25 minutes left, and it's important to.
This is great.
Okay, what else? What else? 18? 8C. Love it. But what was your so while I copy and paste this? What was your so? Is that a diamond?
Isn't that f of g?
How did it turn into a diamond? Hold up. Sorry for everybody I'm wasting your review time. This is called the review?
Yeah.
No. And this would look like this last one? Holy moly, that's a diamond. Have I been putting a diamond on all of them? Well, I don't know. Operators. I just go over here to operators and I try to put in this little circle. Nope. Wow. There is no diamond. Don't. There's no function that's the diamond. No. From far away, it looks normal though. From far away, it looks not like it. Okay, so what's your question? Was your question diamond, or your question is actually on the composition? Oh. All right. So the composition of a function. That's hilarious. To me. How do you compose a function? You plug. Don't say it. It is so ugly.
Professor, I saw one of the math homework, my open math, which is like it had like t less than greater than what is that? I don't understand.
What? That was not a good question.
Okay.
I saw one on the open math that had like the t is less than or greater than that one. What is that?
Like you had this question that which would be the question 11. Yeah, the one with t and n of
Raised to the t.
No, N of like T, and then the T represents temperature, and then the other T is slow, and T is like time.
I'll have to look at it. It was composing a function though.
yeah, but it had like some inequality there. I didn't understand.
I'll have to look at it. It's probably a domain or a range question based on it. I don't know. I'll look and see. But let's do this. F of g is f of, and what am I plugging into that g of x? Yes. And then this is just a review. This is just a review of what we just did, where even if you have something ugly inside of that, you can still plug that ugly thing in for x, right? You can still take the ugly thing that's inside of the parentheses and plug it in for x. That's okay. It's just ugly. Use parentheses. Like add an extra set of parentheses if you have to in your brain. Use those parentheses. So then we're plugging this in every time we see an x, right? So I'm going 3. Oh, if you weren't tracking, we're doing c, just so we know. With parentheses, plug the ugly part in, plus 1. Oh, but it's not even asking us for that. It's asking us to solve it, right? Which I guess now, because this is the simplest form, we could get rid of those parentheses. I just was being careful. Well, that's that, right? So now we have to remember what domain means. It means what can x be, right? All right. So here's what happens. This is really interesting. There's 2 things telling us what x can't be. There's a square root, and then inside of that, there's another square root, right? And we got to make sure they're the same square root. So first things first, let's just look at this g. We're going to look at g first. And we're going to say, is there anything that makes g of x bad? Is there anything that would make that bad? Or yes, a negative. Where? No, not for the x. Under the square root. A negative under the square root is bad, right? So if a negative and let's just write this real slow. If a negative number is bad, then what does that mean we have to have happen?
It must be greater.
What? Don't say it. Never say it.
It must be greater than
Somebody else said it earlier. Don't say it. What? X?
Should be greater than.
Look at the 2 things right there. If a number underneath that is bad, that's negative. What does that mean must be true? Okay, yeah, you're on the right track, but not perfect yet. What it's telling us is that whatever's underneath here, put parentheses around it. I don't care. Put a freaking big box with nothing there, right?
It should be greater than 3.
Whatever the box is should be what? Should be greater than 0, right? Or equal to it. Because a 0 square root is fine too. So what's in that box for us? X minus 3. So our real what this worked out into slowly is that this better be bigger than 0. Whatever's the argument, that's what we call it sometimes, is the argument. The thing underneath the square root. Whatever is the thing underneath the square root better be bigger than or equal to 0. And then you just solve it like we used to with our red line. And say that x better be bigger than or equal to 3, and we're done. There's another way to write that. There's like 3 or 4 ways to write it. One of them is saying 3 to infinity. One of them is saying x is a number such that x is bigger than 3. Was there another one? I guess the other one was the number line. We're not asking you to do that again on this test, but if you were to draw a number line, you do that at 3, and you go like this. Boop. Boop. Oh, wait. I made a mistake. Where? On the 3? Because it can include 3, right? So bracket there as well. Those would be the 3 ways you can write that. Did it turn off again? It's still on? Oh, I don't know. It just decides when it wants to stay on or not. What'd you say? Oh, because it asked us to. That's this right here. We're not done. We just made sure that g of x was good. No, that's a composition. Multiplication looks like this. This is composition. This is putting it inside of the function. Yes. If you see f of g, that is the same thing as f of g. Those two are the same. Okay, wait.
You see, I got confused where, like, you put on the line.
Uh-huh.
Me, automatically, I would think you would shade it in towards this way. Because,
To the left.
Yeah.
Yeah.
Towards this way. But since it can be less than 0, it's not gonna go that way, right?
Well, I don't even think about that. Just pick a random number in your brain. Pick 4. Plug it in. Is 4 bigger than 3? Draw a little circle there and shade that side. Pick another random number. Call it 0 because that's an easy one. Is 0 bigger than 3?
No.
This is 0 over here. It's like 0, 1, 2, 3. You put a dot there. Is 0 bigger than it? Is 0 bigger than 3? Nope. So I can't put that dot there. I can't put any of these dots here. Those are all bad points.
Okay.
I would do that. I would plug in random points. You got your main point. You got your 3. Plug in 4, plug in 2. See what happens. See which side is shade. That's what I would do. Okie dokie. What else? Yeah, you will. They're on here somewhere. 7C? Oh, there. Look, y'all asked the same question. You said, will we have those shifts? Here it is right here. For each of the graphs, sketch these shifts. So that's like 3 shifts per graph. That's kind of crazy. I'll just do 1 or 2. There's 2 7s? Yeah. There's just something. I'm not good at. I don't proofread. That's what it is. I just write and I don't proofread. All right. What am I doing over here? I lost it. I lost where I am. There we go. I will post this document as well as I'll keep working on it next class period, and I'll post this and the next class's documents and videos. So that'd be cool. I'll try to do that as fast as possible, like tonight. All right, 7C. Average rate of change. Anybody remember that formula? Nope. You got to. Yeah. It's the same formula as slope. Remember the slope formula? What's the slope formula?
y2 minus y1 over x2 minus x1.
That's it, indeed. I don't even know if this is actually recording. This will find out. Okay, what's the slope formula? Say it loud. Say it proud. You got to know it.
y2 minus y1 over x2 minus x1.
That's the same formula, right?
R rise over
We just don't have a y. What do we have instead? An f of x, right? So I need to figure out what f of x2 is. Right? Which is f of... Are we doing C?
f of negative 1.
No, we're doing C.
Wait, C, oh.
Sorry. f of 4, square root of 4 times 4, square root of 16, 4. Okay? What about f of x1?
Square root of 4 times 1.
And what can we call those two things? In
Y2.
y2 and y1, right? And now we've got, I think, 4 numbers to plug in. y2, y1, x2, x1 from the problem, and you're home free. You're just plugging them in. Bless you. 4 minus 2 over 4 minus 1 gives me 2 over 3, right? And that is the average rate of change. What?
I sneezed and missed everything that just went on.
Oh, no. That happens sometimes. Well, 4 minus 2 is 2, and 4 minus 1 is 3.
I bet they're keeping that phrase average rate of change.
This is kind of cool, though. What does rate of change mean? Rate of change is slope, and average is not slope. Average is average. So what this is saying is, the freaking square root function looks like this, right? It does. Trust me. You should know. Go memorize your functions.
Yeah.
The average rate of change from 1 to 4 is basically saying, hey, guess what? If we were to calculate that slope, boop, the slope of that red line right there is that average rate of change. Slope of red line. Just a fun tidbit. Fun little fact for you. A little math fact. All right. But you got another problem? Running low on time? Running high on math problems. Which one? The other 7 that Joseph just asked for? Yes. Joseph asked, will we do any shifts? And let's do the hardest one just so you get to see it. We will do C.
And it says, will they be like,
I don't know. I can't promise you. What is the question? Will there be like what? Like multiple shifts to one thing?
no, with the drawings that like that.
Yeah. There will be at least one that has its drawing it gave you. I didn't make it. Though, look, that's a good drawing right there. Those are good ones. Those are good drawings. All right. So let's do C, and I'll let you pick which one we do it for. A, B, or C. Okay, so we're going to do C for A, because I heard of them first. All right? So actually, yeah. So before we even start working on it, what are the 3 reflections? Or negative on the outside.
And it's gonna go
Hang on. Negative outside means
reflected over x-axis.
reflect x-axis. I can only write so fast. All right, what else we got going on?
We have a horizontal
A horizontal shift.
vertical shift.
Sorry. Wait,
down.
who's talking? Hey, they're trying to learn.
Vertical shift down. And a horizontal shift.
Down how many? Don't just say down.
One by one.
Okay.
And you have a horizontal shift.
To the left by 2.
Alright.
I'm just saying, you got it.
Okay, which one do we want to do first? You can do any of them in any order. It doesn't matter. Reflect it first. All right, here's how I would reflect it. Take each point and just reflect the point itself, and then erase that line if you have to. Like with your pencil. Take each point, reflect the point, and then erase the line if you have to. Whoa. Right? So I'm taking each point and reflecting it to the best of my ability. And it looks like that, right? Did I miss any? Which one?
I'm lost. I'm sorry.
Oh, this one right here?
Wait.
What I've done is I've taken each point and reflected it across this red line. Right? Oh, I think I messed up on one of them. Tell me which one I messed up on. The 4, right? Where should it be at? Yeah. Good catch. And then I draw my line, and let's just see if it looks good. You should be able to tell if it looks good or not by what ends up happening. Does that look like a pretty solid reflection?
Yeah.
I think so. And you'd be able to tell. If you messed up, you'd be able to tell real fast. Like, hang on. If I had messed up on that 4, does that look like a good reflection?
No.
Yeah, it has a little hiccup, right? So you can see it and fix it. Okay, now what?
If one of the points was negative, it means it would go up.
Yes.
Reflect across to become positive.
Yes.
And if it was positive, oh.
Yes. Okay. What are some other shifts that we have to do?
We have to go left 2.
Okay, left to green. So I'm going to take my new thing, and every single point I'm going to go over 2. That's the only one off the chart. That stinks. I'm sorry that it's off the chart. But every single point needs to go over by 2 in a new green color. I prefer doing it all in different colors so that I can see. I do understand that when you're taking your test, I know it does. I understand when you're taking your test, you don't have a bunch of colors. I wish there was a better way. This is just the way the cookie crumbles. Looks pretty on my paper because of the colors, but ugly on your paper because of the pencil. Okay? And what is the last shift to occur? Down 1 in blue. This will clear it up a little bit, I think. Maybe not. Oh, I did the wrong one. Green. Green down. Green down. Green down. Green down. Yo. 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 All right? Not too crazy? Chances are they don't want you drawing all 3 of those lines. They just want you drawing one of those lines, so you got to erase the rest of them. Once you get it, erase it. Heck, if you don't want to draw the lines until you plot the points, or if you want to just do the points one at a time. So here, watch. I'm going to grab this for a second. Whoa. That was not good. What happened? Yeah, grab the whole thing. Okay, well, I guess I'm not changing anything.
I mean, isn't it technically you copied something?
Oh. All right. Groovy? What else do we have to do? I'm getting pretty close to have done all of them. It's kind of cool. Any of these rapid fire ones? I think rapid fire is going to look most like, if any of them come from these textbook questions, the 2 and the 3 are the best ones to practice. The one that we already kind of did one of, the 2 and the 3 are the best to practice. Perhaps the ones that look similar to the ones we just did. So, for instance, 26 says passing through this in perpendicular. And above, we had a similar one that we haven't done yet that said passing through in perpendicular, right? So, or parallel. So if there's some down here that look similar to the ones up there, then you can be assured they will probably happen. Like this piecewise one. Or this is going to be terrible to go and sync the 2 videos or the 6 videos. Yeah, which one? One C. Yeah. Will, shall, Carrefour. Anyways. 1C. You're talking about on this thing up here? Way up at the top? Determine whether it has a max or a min. Oh, boom. We can do that in 2 seconds. We can do this without putting a pen on the piece of paper. We can do, not the determine where it is, but determine what the first half of it to get half the credit. You can do immediately. Determine whether it has a max or a min. Let's do C because you asked for it. C's a good one. Doobie-doobie-doo. 1C. Does it have a max or a min? No, we can do it without finding the vertex. I can tell you whether it has a max or a min. How do we know? Well, I got min, I got max. Explain yourself.
It has a max because of the negative 3. The parabola goes like.
Negative 3 means it's sad because he's negative. And sad means he's got a max because he's a mountain. So that's the first half of the question right off the bat. Max, you got half your points. So if you forget the rest, do that. You got half your points. Okay? Now we have to memorize that formula, which is just half the quadratic formula. Negative b plus or minus square root, but you don't need all that crap. Now you just need this. So that's negative 12 over 2 times negative 3. Remember where the A and the B come from, right? Just in case someone's sitting in the back like, I don't know about that. The A and the B come from where? What is going on? Oh, there it is. Sorry, I'm freezing up. It's probably because I'm recording and doing this is why it's freezing. Indeed. Are we back? Whoa. Sorry about this. No, we're not calling it in. And we're back. Well, hang on. We're trying to do this vertex first. Don't get ahead of ourselves. 2 times negative 3. This turns into just a positive 2. So what is that? That is your x value of the... No. It's a part of the parabola. It's an important part. It's the most important part of the parabola of your vertex. And how can I find the y value of any number? Any number, doesn't matter which number. F of 2 now, right? And f of 2 will give me a, this is what I've been yelling for day one. F of 2 will give me a what? A point. Not a y. Don't say a y. Say a point. Because if you say the y, you're going to forget which x goes with that y. I want you to always remember it's a point. And then if you need to go and grab the y for like the average rate of change formula, by all means. But you remember the point. The point stays together.
Would you remind us of the...
Well, after I solve for this. No, yeah. What is it? What reminds you of what?
Okay, it was the terms used to determine what x or y.
What are you saying?
Alright, so there was a phrase that where it occurs or
Yeah, where? Oh, for the max and the min? Yeah. What is the maximum value? Where does the maximum value occur at? So I'll answer that right here once we get this number. That's just 2? Thank you. Trust you. Oh, so your vertex is 2, 2? Well, that's not helpful for what he asked, but your maximum value is? Maximum value is 2. It occurs at, max occurs at x equals 2. Cool. For instance, if you look at the notes, the word problems from last week that we didn't get to, but I really wanted to, we had the football kicker. You just solve the vertex normal style, like you solve anything else, negative b over 2a. But you can find the kicker, I think it was 59 feet away or 60 feet away, I can't remember. He kicks it 69 feet before it hits its vertex. That's your x value. The vertex was only like 20 feet, so it didn't go very high, but it went far. Makes sense for football. All right, what else? Anybody have any last problems as we run out of time? Six B. Okay. And then that'll be the last one we haven't done, right? I believe so. All right. Use the given conditions to write an equation in point-slope form. Here we go. First off, we should know what point-slope form is. Before we even try, we should know what this form looks like. And if you don't know, please go memorize all 3 forms, like tonight. Like, current, like right now. Just go memorize.
Y
Y minus Y1.
minus y1. They all sounded like that?
No. Equals.
That's a,
What are you saying? Which way?
Slope.
X minus X1. Okay. And we're doing B, you said? Sure. Okay. So now we've got to decide some stuff. We want to label this point real quick. What should we label it? X1, Y1? That's helpful. And then we've got to decide what the word perpendicular means.
so,
Negative versus
Flip, flip. Negative reciprocal. Or if you don't like that, think flip, flip. Flip the sign, flip the fraction. Even if it's not a fraction. Yeah. And then the point goes in the point spots. Yes, no math. If it told you right in that format, no math. Like memory, because you have to remember the format of the formula. So you get y minus, your y1 was 5, right? Equals, we're taking this and we're going flip, flip, positive. I always write the positive right there when I do my flip, flip so I don't forget later. Like when I'm just doing my flip, flip note, I always write the positive because I don't want to forget that I've done the flip. But you don't have to rewrite it down here. X minus 0. That's nice. You can write it like that and leave it. Or you can reduce it a little bit by getting rid of that 0. Either way. Both will be 100% correct. Okay. That's cool. And remember, if it's parallel, if the word is parallel, what do you do with the slope? Same. Keep it. That's it, right? That is your slope. Same. Flip, flip, or same. Yeah. Uh-huh. Well, yeah, but 0, 0. I just left it off. Yes, the 1/5 times 0 is 0, right? But 1/5 x minus 0 is still just 1/5 x. So I actually didn't even distribute in my brain. I just said, oh, this is actually technically 1/5 times x. Because x minus 0 is x. That's what my brain did. But I see what your brain did. Distributed, and then it gets rid of it. Both are true. Both work. All right, what else? You.
So the bottom one would be the answer, right? Would you?
Either. I would take either. Top's fine.
Would you like distribute it more, like move 5 to?
No. Yes. If we do move the 5,
It'd be plus 5.
y equals 1/5 x plus 5. And we've just done something, haven't we? I'm green bubbling this because this is a different thing. This is called something. Slope, intercept, form. So now you've answered it in the wrong form from what the question asked you, though it's not wrong because it's the same equation. But what that tells me is two things that I didn't know before. Well, I did know one of them. That tells me that 1/5 is my m, or my slope, and that 5 is my y-intercept. But instead of just saying y-intercept equals 5, what's a better way to say that you'll remember it because I've been stressing this forever? How do you write a y-intercept?
0, 5.
Thank you. It's not y-intercept of 5. It's a y-intercept of 0, 5. I think that's important to note.
So if we put that on the test,
No. This is not this. This is a different format. It asked us for point slope form. It'll tell you what it wants. It'll tell you exactly what it wants. And if you have a question because you don't remember, then write all 3 forms and try to label them, and then circle the one that looks like it matches. But you'll remember. Remember. But if you were to write all 3, label the one that you think is the right one, and then circle that one, chances are you're going to be in a good boat, I think. All right. If you got one more question, let me know. I'm going to pull up the roll while you look for that. What do you want? Just want you to do well. Please study. You got a Friday. You got a Saturday. I promise you, if you send me an email that's the math question, not like a random email like, what are you doing? Or whatever. But if you send me an email that's a math question, I will get, or even a grade. I want to answer grade questions super fast. I've realized this about myself. I'm not great with the logistics of the class itself, but if you send me a math question, I will immediately answer it. Like, I'm really good about stopping what I'm doing, writing it, taking a picture, emailing it back. That's the one thing that I see and I'm like, oh, I can do that. I don't know about gradebook. Gradebook takes me forever to log in, but answering the math question, I will be there as soon as you have a question. So feel free all weekend. Like you did it. No, it's the only one I can think that did it once, but I emailed it back. I said, try this. If it doesn't work, let me know. And maybe it worked, maybe it didn't. I was literally hanging out with some friends. I was like, I can do that. It's more fun than hanging out with friends. Sorry, it's loading. The Wi-Fi, you know. You know how that's what goes. What do you want?
Is there any way I could make up the quiz?
Yeah. Right now?
Yeah.
You can do it after this class. Yeah. I gotta go grab one in my office, but.
Okay.
Yeah. Number 3. Number 3 is the worst one, but it will be there. It's going to be on this test, and it will be on the final. The reason we're practicing it is because we know we'll see it again. And you'll see it again in next class and the next class. And forever you will see this thing. This thing being called the different. Whoa, what am I doing? This thing being called the difference quotient. So here we go. Session 2. I will post the video from session 1. Or not a video, but it's like a screen recording from session 1. I'll also post this tonight. So you'll get all the notes from the people before and the ones they answered. And then you can get all the notes from this one. So here, let's go up and look at session 1. They did the same question, but they did B. So let's do one of the ones that's not B. So pick A or C. A? All right, let's look at A. Okay. So this is kind of what I told them, and I think is the best way to look at this, is this is not one problem. This is 3 problems mashed together. This is this green problem. By green, I meant blue. This actual green problem. And this red problem. This is 3 problems mashed together. Let's take them one at a time and not try to be a hero. Like, for real, take it one at a time. Take it slow. So let's solve f of x plus h. What do we do? What do we do? Most of us are up a creek already. We haven't even started. Well, here's the better question. What would you have done had I said f of 3? You distribute. But I know what you're thinking. I just think that's a bad word because that's a word for it. What would you have done? If I would give you this 3, what would you have done?
Plug it in.
You would have plugged it in, right? Yeah. Don't say distribute. Distribute's a... No, it's okay. It's a word for something else. But you're right. We did put it in all of the x's. We did distribute that 3 to all the x's. Just distributing sometimes means multiplication. So you all knew what to do with the 3. So what do we do here? Plug in what? The equation for A? Okay, let's look back at this again. Did we plug in the equation for 3? What did we do? 3 into the equation, right? So be careful which direction you went. I see what you're doing, but you got to be careful which direction you go. You were going to take this and put it in for 8x, right? But that's not what we did with the 3. We took the 3 and plugged it in for the x's. So what are we going to take? This whole thing, that whole thing, and where does it go? Every time you see an x. So I see an x right away, right? So I'm taking that whole thing, x plus h, and I'm plugging it in for that x. And what did we do to that x in our original equation? We squared it, right? Then we subtracted 4. Then we multiplied by x, right? And then we added 2. I'm pausing because that's the hardest step. What did we where's the hard part? Perhaps it would be easier if I did this. To see, not to do. The blue thing got plugged in anywhere you normally would have seen an X, right? The blue thing got plugged in anywhere you normally would have seen an X. Ugly as it may be. But alas, we're not done. I wish we were. What must we do? We must do math. We must FOIL and distribute, right? This is something to practice. Please go practice the other two. Please, 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 please. I cannot tell you enough. We've done foiling a million times. You have to FOIL. If you don't like FOIL, you can do it in the box method, but you have to know how to FOIL or box, right? So what are we foiling here? What does this all turn into when we FOIL it out? X squared plus XH plus another XH because it got FOILed, not just doubled, plus H squared. There's our first outer inner last. Let's do our distribution at the same time. Save us a step. Minus 4x minus 4h plus 2. Can anything there be combined? The 2 xh's is the only thing I see. This is the hardest one on the test. I'm glad. It's a terrible one to start with, but hardest one on the test. And if we can break this down and practice, then you'll be gold. That is the blue problem. That is the blue problem. That is the blue box that you saw above. Let's find out what the green box is. What is f of x? It is not a trick question. For the problem we're working, which is the top one, right? What is f of x? Just the normal thing. No work needed. Right? That is your green box. Not a trick question. What is h? Not a trick question. It is h. We've answered all three of those problems. Let's piece them together. Let's take the blue box and then subtract the green box, right? And then divide the red h. Did I do that the right way? Yes? Okay, good. But instead of a box, we don't draw boxes in math. What can you use to do the box instead? Thank you. And please do use them, as they help you not mess up your sign. S-I-G-N. So we should have x squared plus 2xh plus h squared. Messy as it is a math problem. Minus 4x minus 4h plus 2. Ugly, ugly, ugly. Regular minus sign. Green parentheses. We've got a green problem. We've got a blue problem. We've got a red problem. Something will always happen with these types of problems every time. If it doesn't happen, take a breather, try a different problem, come back to it, start over. What's going to happen with this negative sign? We distribute the negative accordingly. It turns into a positive. Changes all of those signs. And what really cool thing that I'll do in pink just happened? Look across this whole spectrum and see something cool happen, maybe one at a time. Which one? The negative 4x and the... Okay. Anything else cool happen? X squared and the negative x squared? Okay. Anything else cool happen? The 2 and the negative 2 canceled. Like I said, if that doesn't happen, take a breather, go do a different problem, come back to this one, try again. That is going to happen every time. And if it doesn't happen, then I don't know what to do. Just go try again. Just start over. Just clean slate. It's okay. You did a good thing. It didn't work. We're going to try again. That will happen every time. I can't get you a shortcut to get there. You have to do the foil and the box and the distribute to get there. But that will happen. It will cancel. It has to. If it doesn't cancel all three of those terms, just start over. All right, so what are we left with then? All over the H. And another cool thing will always happen every time. Those terms each have an H in them, right? So you can split it up. You know what happens to all those H's? Cancel. 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 You're left with 2x plus h minus 4. It will always be a simple answer with an ugly way to get there. Promise. Okay? Take a second, breathe it in. Go home and practice B and C, please. Please, please, please. It's just a free 10 points if you can get it. It's a free 10 points. I'm telling you right now. It'll look just like those. I can't tell you the rest of them that it'll look like, but I can tell you that one will look just like those. I know for a fact. So, go practice. Practice, practice, practice that. All right. Jumping back over. Anybody got another one on that review that looks ugly? Pull up the review. Feel free to look at your phone. Pull the review up. Look at all the problems. See if you like one. If you don't like one, which ones look messy? 7 and C. Oh, there are 2 7s. My bad. The average rate of change. The heck you need? I get the first question. Why are you needing the average rate of change? Whoops. Sorry. Just kidding. We'll do them all. If we have time. Hopefully we have time to do everything. And if we don't, say Levy. Paste. This one. All right. Find the average rate of change. Well, before you can find the average rate of change, you must know what the average rate of change is. So the average rate of change has a formula. Can one remember said formula? It's the same as slope.
F of x2 minus f of x1 over x2 minus x1.
Might there be another way to write it if you can't remember that? Might there be another way to write it if you can't remember that? Some people write delta y over delta x, though that's not helpful to solve. Some people would write slope, average slope. All right, here we go. Which one did you want to do of those three? I don't mind. C? Okay. Have we any of our 4 things already? Seems that we have x1 and x2, so we only need to find y1 and y2. Correct? How do you find those things? You plug in the regular ones, right? So let's see. F of x1 equals f of 1 equals the square root of 4 times 1 equals the square root of 4 equals 2. Question that we answered the past 2 classes, and I've been realizing that maybe I should have been stressing from the beginning. Rest assured, next year I will stress it from the beginning. What is this pink underlined thing? What is it? What? Yes, that is it. That is what I was. That's the important thing, right? Ugly as it looks like a long string of things, right? It's not a long string of things. It is one thing. It is a point. It is the specific point what? 1, 2. The ugly string of things distracts you from seeing the point in the weeds. It's a bunch of weeds that's distracting you from seeing. I took an X that was 1. I took an X. What that happened, Marina? It's not like whoa. I took an X that was 1, and I turned it into a Y that was 2, right? I took an X value, funneled it through an ugly system, and got a Y value. And I will do it again for a different X value. Some would call X2, which is f of X. What is X2? 4? F of 4, which is 4 times 4, which is the square root of 16, which is 4, which is also a point, just a different point. 2, 4. Wait, 2? No. Okay. Just didn't know where I came from. And now I think I can plug those two things into that formula. Yay? Which one goes where? Let's say that we can go and just hunt down each thing. I'm going to take this formula. I'm going to copy it. Whoa, not the whole thing. That's annoying. I'm going to rewrite the formula. F of x2 minus f of x1 is kind of like saying 4 minus 2, right? And x2 minus x1 is kind of like saying 4 minus 1. Thus 2/3 is our slope, or our average rate of change. Okay? Possible? Not impossible? If you want to see on a graph, what does the graph look like for that function? The square root function looks kind of like this, right? And so what we just did is we took the point 1, 2 and the point 4, 4, right? And what did we find with those 2 points? We did a y minus y, x minus x thing, right? We found the average slope amidst a not average slope. Each of those points has a slightly different slope. We found what the average of them must be. It's kind of cool. Kind of weird, kind of trippy. We found an average slope on a line that was not a line, so it did not have a slope. It had a billion, jillion different slopes, and we found the average of the slopes. That's what we did. With the point 1, 2 and 4, 4. That's a pictorial way of looking at what we just did. All right, let's hop back over and see. Oh, not there. Let's hop back over to there and see what else we might struggle with. Yes, this is an important one. Number the 8th. Copy and paste. Boop. Which one? Which one do you want to try? Sure thing. Let us find f of, well, I'll write it better. F of g of x is the same thing as f of g of x, right? So what are we plugging into each of the functions? Me too. Same time. I saw that. I was like, yep. What you thinking? Oh, which one do you want to do? I forgot. I should have highlighted it. What'd you say? Somebody asked. I don't remember. Oh yeah, now I do remember. So you're taking that and plugging it inside the parentheses like that. And then what do you do with that once you get that to do for the final thing? So where you see the x's, like that. And that is your, not your domain, but that is your function, right? Careful, it's important to look at what it's asking you for. That's not your domain, that's just your function. Okay? So now we got to find our domain. For a composite function, it was the only weird domain thing. You had to find two things. Anybody remember what they were? You have to find the domain of the inside and the domain of total. Maj, Destiny, and I spent a little bit of time after class talking about this. Remember? And we saw that the domain of the inside mattered. And the domain of the total function mattered. But the domain of the secondary function or the outside function didn't actually matter. And actually, it could screw you up. We were working on a fraction problem where we checked this domain and it mattered. And we checked the total domain and it mattered. But when you go and check this domain, it didn't actually matter. Like the eliminated variable was a fine number to have. So the first thing we'll do is check g of x. G of x equals the square root of x minus 3. And we got to pick the domain. We got to decide what the domain is. So the domain says, what are the bad numbers? Yes, you're on the right track. You said x's. I thought you were saying it had to be big plus meaning bigger than. Sorry. Nope, you're right. I was wrong. I understand now. What are the bad numbers occurring? There be only three things that can make a number bad. And not just negative. You can't just say negative. Any negative number is bad. What? Wait, what? Dividing by? Dividing by 0. Bad. Is that possible here? No, it's not a division. So, but it's still good to know that that's part of our bad numbers. What's another bad number? Square root of a negative number. Bad. And what's the third thing? I can never remember the third thing. I literally can. Oh, I do remember the third thing. We don't learn it yet. It's the log of a negative number. Just like the square root of a number is bad, log, but you don't need to know that. So just the two things. Okay? Well, which one of those actually matters here? The negative square root. We can't have a negative square root, right? Okay, so what does that mean for us and for our square root? It means that we need this not to be negative on the bottom, right? So how can we make this not negative on the bottom all the time forever? Yes, you jumped 3 steps ahead of getting there slowly. But we don't want the bottom to be negative, right? So we want whatever's underneath it, whatever it may be, to be a positive number, right? So what is underneath it in this case? It just happens to be x plus 2. How can we say that x plus 2 better be positive in math terms? X plus 2 better be bigger than or equal to 0. And then we do our little red line and solve it out. And you subtract 2 from both sides. And you arrive where you jumped to and said, it better be bigger than negative 2. It seems like. And there is your bad numbers. So there's your domain for the inside. Now we must do the domain for the total. So this is your domain. X is greater than or equal to negative 2. Is your domain of G. Draw a line. We must find the domain now of f of G. f of g is this function that we calculate. Whoop. F of g is this function we calculated. What could make that a bad number? What can make that function have a bad number? Same two conditions. 1 over a 0, which is, or anything, not just 1, anything over 0. I should say a number over 0 is bad, and a negative square root is bad, right? What would give us a negative square root in this problem? Yeah, the same thing, right? Nothing changed under the square root. It's the same thing. So again, we have the same exact domain. X better be bigger than or equal to negative 2. So that's your domain. Checks out. So your domain is X better be bigger than or equal to negative 2. There's another way you can write that. That's starting at negative 2 and going to infinity. There's another way you can write that. Or draw it more over, which is that number line, where you draw a bunch of numbers, you go negative 2, you draw that hard bracket, and you shade in the right side. I don't want to lose you. I know we're the day before break, but I don't want to lose you. This is important. Even if you're not going to practice tonight, it's important for you to see this so you can try to practice this weekend, Friday, Saturday, Sunday, Monday, Tuesday morning. It's important. What? More questions? More questions? Look.
9.
A number 9? Oh, yeah, 9 we weren't here. 9, we had like 4 people here to learn inverses. So let's just go to do the steps of the inverse. Whoops. Where'd it go? 9C. All right. All right. Was anybody here? We had like 5, 6 people. Who's here on Friday? It's Thursday, whatever. Or was it Tuesday? No, it's Thursday. Wait. No, we learned quadratics most recently, maxes and mins. That's fine. This was on the day everybody missed for homecoming, which was last Thursday. Okay, do you remember those? Anybody that was here remember those steps? We took steps to find the inverse. There are like 4 of them. You set it as to equal to y. Then this is the big step right here, is you swap x and y. That's kind of that idea of an inverse, right? We talked about if you invert your controller and you're playing Call of Duty or something, to invert your controller means you make up, down, and down, up. To invert your colors on your iPhone, make the black, white, and white, black. You know how you see that inverted color mode and it's ugly? Because it looks like a negative on a camera. All right. So we're switching them out. X equals 2y minus 1 over y plus 2. And then what was the last step? Step 1, set equal to y. Step 2, swap x and y. And the last step was to do what? This is the thing that we do all the time. Now we just screwed up our equation, right? Look at that equation. What do we always want to get by itself? Now we got to do some work to get y back by itself. So step 3 is to get y alone. All right, let's try some crap. How do we want to get y by itself? So multiply both sides by the bottom. So it cancels it out. Okay. Y plus 2 times x equals 2 y minus 1. I posit distribution. That's just me posing that to you. X, y plus 2x equals 2y minus 1. Now I put it in your hands. How might we get y by itself? How might y be by itself? Perhaps we get it on the same side? xy minus 2y plus 2x minus 1. Let us get that x out of there. Now we're looking at xy minus 2y. We are almost home. Minus 2x minus 1. We're going to factor out that y. I know that I've lost everybody now because I factored something out that some would call a common factor. But I will pause so we can look at what we don't like. Now I'll divide both sides by that factor. That's the inverse. That's the idea of the inverse. That's the hardest type of inverse, which is a rational function. But still 0, 0. Top of the second. Anybody was wondering? Questions? Ask it. I know you're thinking it. I know I lost you at the y, pulling out the y or factoring out a common y. Maybe I lost you at moving y's over and x's over to one side or the other. Okay. The main 4 points of inverses for those of you that missed. 1. Set f of x as y. 2. Switch x and y. 3. Solve for y. And then the 4th step I forgot to do, which is you can just write it right next to it and write this little special notation of the inverse, which is that's your new y. Rewrite. Those are the 4 steps if you missed class in one quick nutshell. I know that's a whole class and a whole 45 minutes broken down into little one problem, but if I were to practice one of them, it would probably be A. If you were to practice one of those for your thing, it'd probably be A. Just a hint. Hopefully it helps. Hopefully it doesn't. Who knows? Practice A. Go home and see if you can do A or not. All right, what else? What else are we looking at? Anybody have any other woes or struggles? What? 2? The piecewise? We can do 2A. Let us solve 2A. Though this one you should be able to do with little to no help. We should be solid on piecewise. So y'all talk me through it instead of me doing it. This is not like the others. This is easy. It may appear hard when you look at it, but once you get rolling, it's easy. So talk me through what you would do. Not I. So hang on. X is negative 2. Okay. Okay. So you're saying we're using this one? Because negative 2 equals negative 2? Check. Sure. So now you're saying do what with it? Don't say it. Don't say it. Yes. So you plug negative 2 into the bottom one you're talking about, and you get something like, which is just, yay? So f of negative 2 equals negative 5. What is that? Not a trick question. What is that? Yes, thank you. Which point? Yes, the x value gives you the y value, and you graph it, and it's a point, and when you do a billion of those, you get a line. Can be curvy, can be ugly, can be straight. I don't care what it is. This one would be a straight line with the y-intercept of 1 and a slope of 3. Everywhere except for the one spot where x does not equal. Oh, no, in one spot. In one spot and one spot alone. That's funny. And then everywhere else it would look ugly. Question. Could we do the same thing if I said, what is f of 4? Let's pick a better number. 2. F of 2. Somebody else talk me through f of 2. Not f of negative 2. This time f of 2. What would we do if f were 2 instead of negative 2? No? Plug it into what? Plug it in. To where? The top? Why the top? Because x does not equal negative 2. And if we plug 2 in, does 2 not equal negative 2? Is that true? Yes. And if you don't like it, try the bottom. Does 2 equal negative 2? Nah. So then put an x across the whole bottom, because that's bad, right? As soon as you get a bad condition, you don't even want to kind of use it. So we use the top. And you get 2 squared minus 3 all over. 3 times 2 plus 6. Which, if you were to work out, is probably something like 1 over 12. Maybe? I don't know. 2, plugging in, what are we plugging in? 2? Oh, 4 minus 3 is 1. Yeah. 1/12 is not an answer. You know what an answer is? The point, 2, comma, 1 part of 12. Fun way to say a fraction. Some people say that. 1 part of 12. One of 12 parts. Also known as f of 2 equals 1 of 12. What's the question? What's the question? Ask it louder.
No.
It's about math or is it about...
She said, why would you plug it in on both the top and bottom?
I didn't plug it into the bottom and top equation. But I did plug it into here just to check. In my brain, look, I plug it in right here, and I check. Does 2 not equal negative 2? Check. Use the top. Plug it in right here and see what happens. Does 2 equal negative 2? That's stupid. Cross it out. You don't even... There you go. No, you're good. You see what I'm saying? The reason I did that is because sometimes you want to check. Because sometimes it's not as cut and dry as 2 equals or does not equal. Sometimes it's one of those less than or greater than signs, like the one underneath. And you actually do want to go in and check and say, is 4 bigger than 2 or is 4 less than 2? Let's actually look. We won't do the whole problem, but which one of these does 4 fall into? 4 greater than 2? Yeah, I agree. And so you would use the bottom one. So you got to be careful. Sometimes it helps to do this thing and check it. Sometimes you can do it without doing that, and you can just fly through it, and that's okay. All right? Good question. I am hungry. I'm very hungry. I haven't eaten all day. Starving. Does anybody have any food? Three-eye rapid fire. Oh, yes, and I should, because that's a good, yes, I will. And that's a good question, because I'm pretty sure something similar shows up. I'm 100% sure something similar shows up. So he said 3i. I'll just pull all of this so you can practice it later if you want to. Boop. Boop. All right. Hang on. Sorry. Oh, sorry. All right. 3i. Graph. I'll write that a little better. Negative f of negative x plus 1. So this goes back to that transformation section. I see 3 transformations. Talk me through the 3. First person gets the easiest one. What? Oh, it's just a graph. The question is to do this graph. And we're about to go up there and do the graph. But before we can do the graph, we got to brain power out what the reflections, transformations, shifts, things are. You took the easy one. All right, not Destiny. Somebody else now. Destiny set up one. What?
So it's right 1 1.
I disagree. Yeah. You said reflect X? Reflect X? I disagree with the right one. There is a negative sign inside.
Oh, is that B?
X minus 1 is to the right one. Right? Oh. What does this mean? This is... It looks pretty darn similar to that red thing. Reflect Y. Uh-huh. I know. 2 reflections and a vertical shift. Which one do you want to do first? I have no preference. I pick not. Which one do you want to do first of those 3 things? Up one? All right. Blue. Here we go, blue. Are those? This is very hard to see. Does that look like an arrow right there? This is very hard to see. It will not be this hard to see on your test. Let's pretend like that's the original function right there. And it doesn't go far on the left, only on the right. That's fun to, that just gives you a little bit of both things, right? Okay. So you said up one. I genuinely hope that this is not too difficult for you. The other things I get are kind of tough. Questions about this? I hope not. That's the easy one, right? Vertical shift you should have in the bag. All right. Now what do we have to do? Flip it upside down, right? We need to reflect it across both axes. Yes. I'm just interested in what happened to that axis when we the Y didn't change, but the thing we're flipping it around just changed a little because we shifted the whole thing up one. So did the thing we're going to flip it on. We're flipping it there. We're flipping the whole function across that axis, right? So perhaps it's better to do reflections first so you don't have to shift that line with it. But so when we reflected across that axis, it should look like this, right? And then we still have one more axis to flip it across. We must also flip it across the Y. Oh, crap. I did the vertical reflection green. And you get the picture. That was bad of me. We must also flip it across the Y. So this pink thing will be the final thing. This doesn't... nope. I need a better color. Perhaps the black. That doesn't change. These 2 points just turn into each other. And that arrow is going to change, right? The arrow gets flipped. And there is our final graph. And if you don't like it, look at it holistically. Don't look at it as one individual thing. Look at it holistically from the beginning. If that blue thing's the beginning, does it look like it shifted up one, flipped, and flipped? I think so. Instead of looking at it as individual parts, look at the whole thing, look blue to black. It looks like it flipped. Then it looks like it shifted. Then it looks like it flipped again. I'm okay with it. It's pretty easy to see when it's not perfect. It will. There will be a hiccup that looks bad, right? If you don't graph it great, there will be a hiccup. Like perhaps we graphed it too close in, and it looked like that. And then when you look at blue to black, it's like, that doesn't look perfect. It will always look perfect. All right. Let's keep going as we run out of time. What else? This is the best possible time you could have to practice. Look through. Take your time. Look through. Pull up your phone. Half of you are on your phone, half of you are not on the review on your phone. Look through the review. See if there's one that looks difficult or challenging. Yeah. Which one? Yeah. No. One is the most recent learned thing. Oh. Yeah, that's fine too. But I was gonna say one's also hard because we just learned it. No, this is good too. Oh, function questions. Yeah, this is good. Whoa. Function questions is good because you can do them quickly, but you do have to know them in order to do them. Like you can't just assume that you know it because you have to know how to check for functions. There's like ways to check for functions on graphs, when they're equations, and when they're points of sets or sets of points. The heck? Tiny. All right. So when it's a set of points, how must we check? There's one condition and one condition only. X can't repeat. Can Y? Sure thing. That only affects its invertibility or its one-to-oneness. So do we see any X repeating? 7, 8, 9? Give it a green check mark. 5. Whoa! Not a function. I'll just write not. Okay? All right, well then what about when we're doing this thing? Vertical line test. I draw a vertical line, or I use my pencil, and I just slowly move it across until it hits the point twice. Holy crap. It's hitting it like, whoa, don't do that. It hits it like 3 times, doesn't it? 1, 2, 3. Therefore, it is not a function. Let's skip and do this one, so we'll come back to D just so we can practice. Is this a function or not? It is. It looks like, at first it's like kind of confusing because it's like just a long and it's repeating. But there's no point when I draw this line across it where it hits it twice. Therefore, ergo, check, function. All right. Now here is the tricky one. Function or not? Why do you think no? Because of y squared. That's a good reason. Yeah, that's going to mean no. The y squared means no. But if you don't like that, y squared equals 100 minus x squared, right? How do you get rid of that y squared? Square root it. And what must we introduce every time we introduce the square root? Y equals plus or minus the square root of all that crap. And guess what we just decided that happens? We just made, even though it's weird to see, x repeat. We just made x repeat. Because for one given y value, say that y is, I don't care, 7. Guess what we have? 2 different x values, right? We have a positive square root of 100, and I don't even need to solve it. I'm not trying to solve it. I'm just showing that I've got 2 different x values for my y value, right? That's two different numbers. Those are different numbers. So if I were to write those in those set form, this is just for fun. If I were to write those in the set form, the point would be x goes first, right? X goes first. So whatever this ugly number is, once we solve it, right? Comma 7. And then there'd be another point. Wait, now I'm getting confused. That's not the same point. This is a bad example. I mean, no, this is just a bad way to keep going through the problem. Because that would be y repeating, not x repeating. Plus or minus. Wait, did we mess up here? I need to think longer on this. What have I done? Can anybody help me for extra credit on the test? What have I done where my brain is getting so convoluted that it can't? X can't repeat. Is that a fact? You yelled that and I just trusted you. That's function? That's correct. That's correct. Because if we were to graph that point on a graph, 5, 7, 5, 8, 5, 9 immediately fails the vertical line test, right? Because of those, I just graphed that second thing, failed the vertical line test immediately. So then why wasn't this a function based on that plus or minus of the y? That's what I'm trying to figure out. What McKenna said was right. You see that y squared, you immediately go, not a function. Y squared can't be a function. X squared can be, because that's the parabola. That's a function. But y squared's bad. But why? Extra credit if you can think through it. What? Why? No, yeah. Talk us through it.
So it's because if you solved it,
Mhm.
say y is like 4 or something.
Okay.
4 can equal one value of x and a different one. So there would be on the graph y would be in the same place, but there'd be a x that was higher up and one that was lower down.
Right, but that doesn't. Yes, correct. You said y would be in the same place, right? But there'd be like an x that was higher and an x that was lower, same y. And that's what I'm saying. That's allowed. But I see what you're saying. I'm trying to get this to like a. Yeah, so like say we did pick 4, right? 4 equals positive square root of 100 minus x squared. We got to get a 16 in the middle. 100 minus what gives us 16 in the middle? That's not a pretty perfect thing. Pick 6 then. 6 works because then we need a 36 in the middle. The opposite of 36 is 64, and that's 8. So that would be x equals 8. So 6 equals plus or minus 8. Well, that's not true. If x equals 8, then y equals 6. If x equals 8, there it is. When you plug in a number for x, right? You get 2 numbers. You get 2 y's. So you can work backwards. You don't even have to split that y up. We were plugging a number in for y, or I was in my brain. I was plugging a number in for y and getting an x. That's not how you do functions. You plug a number into x, and you get y. So if I plug a number into x, 2, I'm going to get a plus number and a minus number, right? If I plug a number in, I'm going to get a plus, 1 square root of 100 minus 4, and a minus square root of 100 minus 4. Now I've got 2 as my point, right? And I've got the square root of 100 plus 4 and the minus. That's bad. And yeah, you're right, it will be a circle. Because that's the circle with the radius of 10, is what that is, if you can remember back to geometry class. But, okay, that was a lot of work for nothing. You don't need to know that. Not on the test. Fun to explore. Me and you both plugged in a number for y. We don't do that. We plug numbers into x. We don't plug numbers into y. We never have. Ever. Literally. Maybe one time when we're setting it equal to 0. That's the only time, ever. All right. Sorry. Back to the review. What else? Rapid fire 32. This might not be helpful. That's exactly what we already did. Didn't we? Or maybe we didn't. The domain, we could do this pretty quickly now that we've established it once with notes, but the domain of something under the square root, anytime you have something under the square root, crap. How do I place there? The only bad number I see. The only bad number that can happen is what? Is the square root of a negative number, right? I see two things that could make that happen. If x plus 5 better be bigger than or equal to 0, and x minus 1 better be bigger than or equal to 0, which means x better be bigger than or equal to negative 5, and x better be bigger than or equal to 1. And if I graph that, it looks like this. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. And I'm saying x better be bigger than negative 5, right? And x also must be bigger than positive 1. So where are both of those true? Just the green section, 1 to infinity. Because if I get a bad number, I get a bad number, right? If I plug in the number 3, or negative 3, rather, if I plug in negative 3, this one works out fine, but this one does not. And you can't get an equation. Like, an equation is not okay if there's just not one bad number. Like, that's bad. This is bad. And likewise, 0 would probably be bad too. Like, you can't say, oh, just because one of the square roots worked out, I can solve it. No, they both have to work out to solve it. So they both have to work out to be a domain. So there's my domain. All right. What else? As we run low on time. Anybody else?